So now this scenario is going to be only slightly different because I'm not going to be adding in the because I'm not going to draw the entirety of the linked list, because since it's anywhere else, we know it's not the head. So I'm just going to assume it's somewhere in the middle of the linked list, some mystical location in the middle of the linked list. Okay? So I'm going to draw one node over here. I'm going to draw a node over here as well. I'm going to draw another node over here as well. Okay? And there, that one points to that one. That one points to that one. Right? And I'm going to say that this is the one at index I. This one, sorry, this is at index I minus 1. I minus 1. It does have that annoying tendency to replace everything, to make everything uppercase. And I minus, sorry, I plus 1, right? These are relative indexes, right? This is some index I minus 1, I plus 1. And what we're doing is that we're assuming for our add method that we've got this other node here, right, which we've called temp before, right? We've got this other node here, it's called temp, or another way to look at that, right, is we've created some node, right, and I've got this text box, or I've got this variable over here represented by the text box. Oof. Let's fix that up. Come on. There we go. And that one points here. Boom. Right? Now, the idea here is that I want to get I want this to be the new index I, right? So this should be the index, right? Say that I is 5, I'd like this to be index 5, and this to be index 6, and this one to be index 7, and this would remain index 4, right? This is currently index 5, this is currently index 6, this is index 4. I'd like this to be the new 5, which would make this one 6 and 7. Okay? So how do I do that? Well, let's first look at the end result of what I want, of what I'd like. I'd like this to be pointing over here, right? So I will just simply take this and point it this way, and I need to do this, and I'd like this to be over here. Unfortunately, I can't do that in that order, right? Because if I point this over here, then I'm going to lose these guys over here. Whoops. Okay, so let's go ahead and work our way through it. But let's look at the end result again, right? I want this to be pointing over here, and this to be over here, right? And remember, I got to be careful of what arrows I move around, how the .next pointers get manipulated, because if I end up if my program ends up basically being represented by this drawing at any point, the garbage collector comes in and starts deleting all of this, which we definitely don't want. Okay? So what do I do? Well, I've already created my node. That's over here, right? Up here, we've already created the node to add. So the next thing I need to do is actually I have to manage to get these guys over here. All right, I actually need a variable to represent them. They're somewhere in the middle of the list, right? And I only have a reference to the head of the list. Fortunately, we just did write a method, the getNode method, that will get us a node at an index, right? So that's the point of writing that. So how did that work? Well, we went over how it works in the last video, but how can I use that? Well, okay. So the first thing I'll want to do is probably, since I don't want to move this first thing I need to do is attach this over here, right? So your first instinct may be to do this, right? Ask for the node at the index you want to insert, right? And we'll just call it node, right? Get the node at the index you want to insert, and just simply attach it like that. But the issue comes in the next step, where I would have to now take this and attach it, and then I have to attach this over here, right? But I don't have but from this location, I don't have a way to refer to this arrow, right? Node only knows about the value that's stored in this guy, right? I should make this explicit. Node points here. node is I, right? And we were able to attach like that. So this allows, so this node over here only has this arrow. It doesn't have a way to refer backwards, right? Singly linked, it's a singly linked list. It only goes in one direction, right? When we learn about doubly linked lists, the arrows go in two directions. But this is a singly linked list. So we're in a bit of a, so this gets us to a dead end. So instead, what we have to do is take this node, is we still use the get index, but we use it to get the node. So let me actually delete these things. Get the node before we want to add. And we can use that to find this guy, the index we'd like to get in front of, attach there, and then move this arrow over to here. Boom. So let's go ahead and translate those into these steps into code. Right? Because these things do work best. I find that this works best when we do have like a graphical tool that I can just use alongside this. So boom, control, there we go, and there we go. All right, and distraction-free mode, boom. That's nice and blank. All right, so let's go ahead, and the first thing we need to do is create this node variable. And okay, node e node. Or if you want to, because otherwise it might start getting a bit cluttered, we'll call this one before because it's the node before the index we want to insert. That's a better name. Always give things better names. Right, that way we're explicit about what we want to do. Okay. Now which node, so we've created that. So now that's what we have. So this is currently what we have. Now what would I like to do? I'd like this to be referencing that node. So it should be equal to get node at, well, index -1. Right? It was fairly easy to figure out. So let's go ahead and draw to represent that. Boom. Oh, and apparently I forgot to do this arrow over here. So right, we created the node before. This arrow was already there. We created the node before. Now we said get node, and that allows us to draw. And now we draw this arrow over here. Boom. Okay. Yeah, sorry about that. Okay. The next thing we are going to do is to attach this. Is to attach this over here. Okay. So we want to move. We want to store something in temps.next pointer. We want this. We want I to be temp.next. To be we want the memory location of this node to be stored in temp.next. So we want it. We know what we want to store it in. Temp.next is equal to. Now in this case it was head. Here we want this node. So how can I refer to this node? Well, we've got before. And this actually stores the memory. It already has the memory location of this node over there, right? I-1 has the memory location of I, before.next, right? This refers to this before.next, resolves into this memory location over here, which gets stored in temp.next's variable, which, okay? And now, we need to adjust this. Before.next is equal to temp. Alright, so let's go through that again. Now that we've got the code all up and running. Okay, so we've got the node we'd like to add. We get the node before the location we'd like to add it to. We get that node location. Before.next gets us the location of the node that currently is in the place we'd like to take. And we make it, and we now get, so now that we know where it is, we can point to it. We take its memory location and store it in our next variable. And then we need to say, well, okay, if this needs to go, if this, so this says now if this is going to go away, if this guy's going to be the new guy after me, then I need to point to it. So we'll point to, so before we'll point to temp, because now that puts that in the proper order. So now this guy will be I. This will be I plus 1, right? Because over here, oops, did not mean to do that. This will be I plus 1, and this will be I plus 2. And there we go. So that will work. All right. We can see now that it will work by adding at index 1, 2, 0. Right? And this should just confirm that we don't get any null pointer exceptions. So A, B. So let's run this again. So A gets added to index 0, B gets added to index 1, C gets added to index 2, D gets added to index 0. Let's go ahead and add E in between A and B. That would be index 2. Okay, and that's it for all we need to do for adding. Now, we don't have to worry about, by the way, adding to the end. So that allows us to get this other add method, by the way, which is adding to the end. Right, this one over here, rather than returning false, we can now say return true, and just simply call this dot add to index size item. Right, so now this will call this one and tell it to add to the end. And this will get, and so how does that work? How do I add a node, say, at the very, very end of the list, like this one? Okay, so let's go ahead and delete that, because these won't exist anymore, right? Before will be deleted, this reference will get deleted here, and the reference to temp will get deleted at the end of the method. So now how does this work for adding an item to the end of the list? Well, we're adding this node over here. Right. This is our temp node over here. We want to add it to the end of the list. So that's at index size -1, right? We'd like to add this guy to index size. So what are we going to do? Well, we want to add this guy to index size. So we get the node before that. So size -1 would be before. We say temp.next is equal to before.next. Before this .next is null. So this temp.next points to null. And before.next, we set that to temp. And that's it. That's how we can add to the end like that. It works very, very well. So the next stack of stuff we have to do is the remove method.